Hi, we're going to talk a little about how some of these ideas are used in the real world, because I get a lot of like, what would I ever use this for? Insert eye roll, right? And so just to kind of give you an idea of times when some things in our everyday life might use an inequality. So if I had this scenario about Holiday World, and then I said, based on age, which ages pay $39.99? Well, I really don't want to list like 3, 4, 5, 6, all the way up until I get to 60. So I would want to think like, okay, how could I do this? Well, I'm sorry, based on age, pay $39.99 would be over 60. So like 61, 60, 61, 62, 63. I don't want to list all those. Sorry about my flub up there. So I could say like the ages. So instead of listing a bunch, I could just say ages that are greater than or equal to 60, right? Because it says 60 or over. Heights that pay $39.99 based on their height would be under 54 inches. So we could say height less than 54 inches. So it said under 54. It didn't say 54 or under, so I didn't use the line. Ages of those that pay $49.99. This is actually a compound inequality because it has two restrictions, right? Because it's not just everybody under 60, people under 2, like it's like comparison up both, right? So people 2 and under wouldn't include them. So this would be from 3, X is going to go in the middle, 60 is up here, so people who are greater or equal to 3, or they're less than 60. Or I could have used less than or equal to 59. That would have said the same thing. If I'm including like 59 and 6 months still being, I would say I'm 59. I'm not 59 yet, but anyway. So these are just a few. You're not going to have like a test over this part, so if you're getting a little anxious, try not to be. So if you were told, told you're doing gift exchange and there's a limit of $20, then that would mean that we can spend less than or equal to $20. And we've used some of these words. They were in our notes yesterday. So minimum voting age is 18. That means people greater than or equal to 18 can vote. The hotel's maximum nightly charge, it doesn't mean it's going to be more than that. It means less than or equal to the $3.95. And the minimum wage, that means legal hourly wages are greater than or equal to $7.25. So those minimum, maximum, you had some clues about that from yesterday's notes. And then it could have really big numbers. This is actually for Anderson. I actually looked this up online. And the 2016 approved budget was $31,613,448. So the amounts of expenditures that would be within the budget, well, if they spent $1, sure. If they spent $31 million, yep. If they spent $31,613,447, yep. If they spent $30 million, yep. I don't want to list all those. I'd be here all night. So I would say X is less than or equal to this amount. So if it's a budget, it's always, you want to stay under or equal to that amount. So one of those that kind of snuck in there actually had a compound inequality. But if you look at these notes, I think this is page 12 perhaps. You should have something that looks like this. Compound inequalities. And most of you are familiar with the idea of a compound sentence or compound words. For instance, the word sidewalk. Side and walk. And then they were used together so many times that sidewalk became one word, a compound word. Chalkboard, compound word. All right. So compound inequalities also have more than one part. If you've been in a science class, an element has only one kind of atom, but a compound has more than one kind of atom. It has more than one thing that it's made up of. So same kind of idea. So we're going to show here how we kind of how this happens, why we need compound inequalities. So we're going to first write 2, and then we're going to try to put them together. So we want to buy a ticket, and the cheapest tickets start at $25. So all of the tickets are greater than or equal to $25. So that would be here, like K1 and K2, and going this way. But you are not willing to spend more than $35. So you're saying, I'm spending no more than, right? So not willing, no more than $35. I think more than got in there twice. Sorry about that. More than. Which really felt completely like. So remember, no more than actually means less than or equal to. That's the amounts you're willing to pay, which is here and back. I mean, you'll buy a ticket for $2 if you could, but unfortunately, the cheapest any of them are is $25. So the prices that you're willing to spend and are actually real prices for the ticket are the parts of these two graphs that overlap, right? The between 25 and 35. So what are you going to spend for a ticket? You're going to spend between 25 and 35. And that's part of what we're going to look at in question B here. Oh, discard. So all the prices you would be able to, we don't want to like list them all. We're just making the graph, and then we're going to write that. So it would be between 25, between 25 and 35. And 25 and 35 are included. So when something is between two things, we're going to write the smaller number to the left, the larger number to the right. We're going to put the X in the middle, and then we're going to be using less thans, and because these are filled in circles, they're going to have equal to. Please keep in mind this part. Think of how the X is related to the 25. The X is bigger than 25. Notice that when I'm just looking at this part, the X is on the open side. So when I compare X to 25, it's bigger. But when I compare the X to the 35, it's smaller. So X is between, just like it looks like, it's between 25 and 35. If you go from small to large, you're always going to be using less than signs. In both cases, they can't go two different ways in this kind of problem. It doesn't make sense. They're going to go the same way, both pointing to the left, if you're going from least to greatest, and then you decide if they're underlined or not. In this case, those numbers were included, so they were underlined. They can be one of each. That is a possibility. if we have, and then we would have one open circle and one closed circle on our graph. So I'm going to just slide on down to this. When something says and, we want to think about where the two things intersect. And typically those are the ones that are going to be written on iExcel. They're already pushed together, like my last answer was. The ones that say or, you're going to graph them separately on the same number line, and they're typically going to go away from each other. So let's look at number 1. If they are written apart with a word to start with, then I'm going to solve them separately. So, had lots of practice with this today. More of those 2 steps. Divide by 2, divide by 2. And I get x is less than 3. And then I work the other side of the problem. 2x plus 8 is greater than or equal to 4. Subtract 8, subtract 8. 2x is greater than or equal to negative 4. Divide by 2. X is greater than or equal to negative 2. Now if I arrange that from the smallest number to the largest number, so negative 2, 3 is here. Since it's and, let's think about this one is here, and it's heading that way. This one is here, he's open, and he's heading this way. Do you see that this part is the part they both cross? That's the only part that's actually part of this answer, because the answer is supposed to be the part that makes both of them true. So where they would intersect would be between those 2 numbers. And so that's why we're going to write this way. The negative 2 has the line underneath. Notice I switched that symbol, but it was open to the x when compared to negative 2. This is also open to the x when compared to negative 2. And x is less than 3. So when I put those 2 things together, I don't need the word and now. It's understood that it's an and. When I put them together, and then I see the x is between those 2 places. So my graph's going to look more like that. Hopefully not too intimidating. It's like a twofer. You get 2 problems all in one. All right, so I'm going to go and do one of these or problems. I'll probably just choose the one in number 4 since it'll be right there. I can work it from the spot. So on number 4, if it's or, you work them completely separately, and you should anticipate when it's or that the arrows are going to go in opposite directions. So I'm going to subtract 11. So I just work these 2 problems independently, and then I leave the word or there. And then the other side I need to minus 9. And so this one I got y is less than negative 1. So I graph them both separately, but they just share the same number line. So the y is greater than or equal to 1, greater than or equal to 1. So closed circle and heading to the right. My other one, open circle, right, because no line underneath, and y is on the left side, so it's heading to the left. So bigger than this number, or equal, less than this number. So ors, we should anticipate, are going to go opposite directions. So I know what you're wondering, what's that going to look like on iExcel? Well, I'm getting ready to show you. Okay, here we are in iExcel, and I have recommended 12 through 14. All right, so you don't need to worry about K10 and K11, which since they're not in your recommended list, I don't think you'll just keep going. But along with K3, that's not assigned. I also did not assign K15. All right, I did not assign K15. it's just more, it's solving and then graphing, but you're going to have graphing practice in K-12. So if you would get finished and you want to do that one also, you're welcome to. You will probably be pleasantly surprised to see that there is not like word problems here. It's just a little extra something for you. So here, this is just asking us to make the graph. So when you make the graph, if X is in the middle, you want your shading to be in the middle. So I'm going to start out putting an open circle at 4, and I know it's open because when compared to 4, there is no line underneath. I'm going to put a closed circle at 6, and notice if I want it to be in between, if I just do those two things together, it makes it in between. And that's it. So -2 gets an open circle. 4 also gets an open circle. So when X is in the middle, the shading is in the middle. All right, so I didn't have to write on the screen much, so I think it stopped recording. So I'm not sure, but I don't want to lose the 15 minutes that I know that I did record. So I'll be writing on the screen here and there, even though it's really not necessary to demonstrate this. So K-12, when X is between, the way you're going to do this, so this means I want a closed circle here at 6, and I want a closed circle at 7, and I want my shading in between. So closed circle, shading in between. So open circle at -1, open circle at +3, and the shading is between because X is between those two. When we have an or, we should anticipate they're going to go in opposite directions. So this one is here and going this way. This one is over here and going that way. And they both have the lines underneath, so they're both going to be solid circles. Oop, close again, sorry. And closed and to the right. So ors are going to go away from each other. Now, and is just a different way to write the ones that are between. So let's think about what this means. What this means is that there would be, if I graph them separately, this one would be going this way, and the other one with the 10 would be going this way. But the part that makes both of them true would not include this stuff. It can't go past 4 and it can't go past 10. So this is just another way to say that 4 is less than or equal to 10. I mean that, well, 4 is less than or equal to 10, but 4 is less than or equal to X, which is less than or equal to 10. That X is between 4 and 10. So and is still going to be between the two numbers. So you'll hit number. Maybe changing the, might be changing the circles. So if X is between, I just go to both numbers. Solid, open. So again, it's an and. That's the same as if it was between. So bigger than negative 20, and it's also less than negative 17. So it can't go past those two boundaries. The or ones are the ones that are going to go away from each other. That's another, like what we've done so many times. Again, more of the same. Hasn't given me very many ors. In the challenge zone, in this case, it doesn't get harder. All right, I think the ands might be the trickiest part of that, but still not bad. So then in the next K that you're going to do is K13. Again, your recommendation list is so wonderful for that, instead of all that scrolling that I'm doing. And so now you're trying to choose the right inequality that matches this graph. Now, if I see two open circles, then open circles mean no lines underneath. So nope, nope, nope. So if just looking at, do I have the right symbols? These all have 2s and 4s, and X is in the middle all the time in every choice. So this, we should be able to easily rule out a couple of these. These two, no way. It has to be one of the ors. So then I also want to check, what about my circles? I don't want any lines underneath because both circles are open. So that top right, there we go. So that's how we're going to write inequalities from the graph. You're choosing the right ones. That was K13. And then K14 will be your last assigned lesson in K. And this is solving them. And we did just a little bit of that on that worksheet, but I did not do too much because I knew I would want to get some examples from IXL. So this has or, so we solve them both separately. So if I'm doing G minus 15 is greater than or equal to 1, we would add 15 to both sides. Just a one step there. So then it's G is greater than or equal to 16. So already, those two, no way, because they don't even have the right sign. And then if we subtract 8, we get 12, but it's a less than. So I may not have even needed to do that. I could have just paid attention to the signs. So on the multiple choice, you may or may not need to actually solve. If you pay attention to the signs, there is no process that makes that line like fall off or get added in the middle of a problem. So this one has the line, that one doesn't. It has to be an or. Okay, so here's one, and this is normally how you're going to see these written instead of with an and like on our notes page. So we usually think whatever we do to one side, we do to the other. Well, we're going to do to all three parts. These symbols, like divide it kind of into 3 sections. I still want to get the 10 by itself. I'm not trying to get rid of that 3. I'm not trying to get rid of that negative 7. I'm trying to get X by itself. So to do that, I need to add 10. To maintain the same relationship, I also have to add 10 here and over here. Because really, this is like, this is one and this is another. And we're just doing them both at the same time. So then 3 plus 10 is 13. Keep my symbol. X is now by himself. Negative 7 plus 10 is positive 3. So So if the x starts out in the middle, the x is going to stay in the middle. It does not switch from being between to being an or. And then we want one of them without the line, one of them with the line. So it would be that bottom left. So again, perhaps with the choices, you might not find that you need to work it out, but I'm showing you some of these for examples so that if you get problems later on that do not have choices. So this has or. An or cannot magically become an in-between. So this and this, no way. Then if I look at my symbols, they have to stay the same. And so then, if we look at that, I see it's an or. I see this has a line underneath, this one doesn't. It has to be that one. So let's jump up here. I don't think this is going to stay multiple choice. Here we go. Now it's not multiple choice. So we have to know what to do because we don't just have multiple choice to guess. Although some guessing, if it's educated guessing, it's not really guessing, it's using process of elimination. So remember, you want to get the v, whatever the variable is, you want to get it by itself. So I'm going to add 19 to get it by itself. But if I do that, I have to add 19 to the negative 20 and add the 19 to the negative 17. Because really, this is like I'm doing two inequalities at the same time. Negative 20 and plus 19 is negative 1. Those are gone. Symbol stays the same. We did not multiply or divide by a negative, so it's not changing. Negative 17 plus 19 is positive 2. And then that's what we're going to type in the box. Negative 1 is less than or equal to, and then v, and then 2. If I can remember all that. So negative 1 less than or equal to, watch the variable because they're going to switch it up often, and then less than, and then my 2. When you get these answers, like negative 1, if you covered up the v, negative 1 is less than 2. That needs to be true. If it's not true, then something went wrong with your math. So these, when it's an or, you're going to solve them separately. So for the left side, I would add 19 to both sides. Negative 15 plus 19 is 4. For the right side, I would subtract 15 on both sides. 13 minus 15 is negative 2. So j is greater than 4. J is greater than 4. Or j is less than or equal to negative 2. Okay, so more of the same. That is the last lesson in the K's. Tomorrow we're going to do some review, and then I have a quiz for you. Tomorrow, that's like tomorrow, Thursday. It's still actually Tuesday right now, so I have to make sure that I've got things in my head correctly. So hopefully those things are helpful. Friday, I actually have a workshop in the morning. I will not be available until 1 o'clock. Miss Elena is available Wednesday evening, so if you feel like you need some tutoring, please get in touch with me. And then no, I take that back. I think it's I need to double check if it's Tuesday and Wednesday or Monday and Tuesday. But anyway, if you need help, let me know, and I will try to hook you up with a tutor if I'm not available, since, I'm teaching class all day. All right, guys, thanks.